All right, guys. So today what we're going to be doing is we are really going to be reviewing special right triangles and trig and some of those old ideas that maybe we haven't seen in a while. So if you guys are looking at this worksheet and you're like, okay, Miss Winkle, I know how to do, up through problem 9, no problem. Feel free to skip forward in the video until you find something that maybe you aren't as comfortable with. If you're like, nope, I want to see everything. I just want kind of a refresh on everything before I try any on my own. Just go ahead and watch whatever you guys need. I'm going to go ahead and do one problem from each section with you guys, and then I'll ask that you complete the rest of it on your own. If you guys have any questions, please go to that link on the Google Classroom. During my office hours, I'll be happy to work with you guys. Or if you want to do something outside the office hours, just send me an email and we can schedule that. Okay, so first, let's go ahead and start with number 1. We want to simplify the radicals. So, and it says the first one's done for you as an example, and we're going to do that now. Okay, so simplifying radicals, remember what we want to do is we want to take a look at what's inside of our radical, and we want to see if we can break it up into a perfect square times a number. So when I look at 20, I want to think about, okay, what are the perfect squares that I could have? The perfect squares, I have 1, 4, 9, 16, 25, 36, and so on. So, thinking, okay, which one of these perfect squares fits inside of 20? Well, 4 does. 4 times 5 is 20. So I can rewrite this as 2 times the square root of 4 times 5, which is 2 times the square root of 4 times the square root of 5. And then I can simplify my square root of 4. So I would have 2 times 2 times the square root of 5, or 4 square root 5. All right, let's take a look at number 4 next. We want to multiply the following. So when we take a look at this, when we are multiplying, we want to be multiplying the like pieces. So in this case, I have what's outside of my square root that I want to multiply, and I have what's inside of my square root that I want to multiply. So when I multiply what's outside, I would do 2 times 3, which is 6. And then the square root of 2 times the square root of 2. So I multiply what's on the inside of each one. So I would get the square root of 4. So just so that you guys can kind of visually see that a little bit better. 6 came from what's on the outside. This 4 came from what was on the inside of our square root. Well, now I know what the square root of 4 is, so I can rewrite my square root of 4 as 2. So now I just have 6 times 2, which is 12. All right, simplify the following ratios by rationalizing the denominator. So when we're talking about what does it mean to rationalize the denominator, that means that I want to get this square root here out of my denominator. We just don't like to write things with square roots in the denominator, so we just want to get rid of that. So in order to do that, I have to multiply my denominator by something that would get rid of the square root. Well, in this case, the simplest version is going to be just multiplying by whatever is that square root that's already in our denominator. So I want to multiply this whole fraction by what's in the denominator, so the top and the bottom. And the reason I want to do both the top and the bottom is so that I don't change the value of my fraction. So remember that if I have the square root of 5 over the square root of 5, that's the same as 1. So multiplying by 1 doesn't change my value. So if I multiply my numerators, I get 4 square root 5. If I multiply my denominators, I would have the square root of 5 times the square root of 5, which is the square root of 25. Or I could simplify that down to 4 square root 5 over 5. And then I would just want to check and make sure that I can't simplify anymore. But I can't simplify my 4 and my 5, so I'm done. All right, let's go on to number 10. Number 10 says we want to find the missing side length or lengths using the Pythagorean theorem. So in number 10, there's a couple things that we want to just remember here. What do these little hash marks mean on number 10? So these blue little hash marks. Hopefully you guys remember from geometry, those mean congruent, or that we are the same. So what this tells me is that this bottom side and the height are going to be the same. So I'm going to have 3 over here for my height. So if I want to find what my hypotenuse is, I just want to use my Pythagorean theorem, and I'm just going to call this side x, just so that I can be consistent. So I'm going to say that 3 squared plus 3 squared equals x squared, or 9 plus 9 equals x squared. 9 plus 9 is 18 equals x squared. Now I can square root both sides. So x equals the square root of 18. But just like what we were doing up above in problem number 1, we want to see if we can simplify this square root. So I'm going to rewrite this over here and say, okay, so x equals the square root of 18, but I want to try to simplify this. So again, we think what perfect square goes into 18. In this case, we could break this up into the square root of 9 times 2 equals x. Then x equals the square root of 9, the square root of 9 times the square root of 2, or x equals 3 square roots of 2. All right, so now we're going to kind of go into those things that we probably haven't used for quite a while. Excuse me. Our rules for 45, 45, 90 triangles. So what I want to do in this box is I want to go ahead and just draw a 45, 45, 90 triangle. So I'm going to have 90. Both of my angles are going to be 45 degrees. Okay. So one thing we should notice about this is if I have 45, 45, 90, that means 2 of my angles are the same. So if I have 2 angles of a triangle the same, that means I'm going to be isosceles. So if one side is x, the other side is also going to be x. So what is that length of my hypotenuse going to be then? So we talked about this when you guys were in geometry, but I'll go ahead and tell you what it is first, and then we can go ahead and work through it if you would like. So this third length is going to be x root 2. So we can get there using our Pythagorean theorem. So if I'm saying that x squared plus x squared, so my two legs, equals, I'm going to just call this third side my hypotenuse squared. So x squared plus x squared is going to be 2x squared equals my hypotenuse squared. Then I could take the square root of both sides. I'm sorry, I don't know why I just did that. If I take the square root of both sides, I would be left with the square root of 2x squared equals my hypotenuse. But I could simplify x squared is just, the square root of x squared is just x. And we have the square root of 2. So that hypotenuse is x root 2. So for any 45, 45, 90 triangle that we have, my legs are going to be the same value. My hypotenuse is going to be the length of my legs times the square root of 2. So if we want to use this rule on number 12, they give us the hypotenuse and we want to find our legs. So if we label this like we labeled our example, this would be my x root 2 side, this would be my x, and the other leg would also be an x. So if I am looking for x, and I know that my hypotenuse is x root 2, I can find that leg length by doing 12 divided by the square root of 2. So 12 divided by the square root of 2, so this is equal to my x value. But what I want to remember is that I can't leave a square root in my denominator, so I am going to have to rationalize this. So I'm going to multiply my numerator and my denominator by that square root of 2. So I'm left with 12 square root 2 over the square root of 4, or 12 square root 2 over 2. And here I could simplify, I could divide by 2, and I'll be left with 6 square root 2. So my legs are 6 square root 2. All right, so now we are going to want to look at an equilateral triangle. So actually, I'm going to let you guys do number 14. And I'm just going to do the rule for 30, 60, 90 triangles with you guys. So if I have a 30, 60, 90 triangle, I'm going to go ahead and draw that out. My 90, 30, and 60. And when you guys do number 14, you'll see kind of where these ratios are coming from. But I'm going to say that my bottom is going to be my x. My hypotenuse is going to be 2x. And that height is going to be x root 3. So when you guys do number 14, you will find all of those different ratios. Okay, number 15. 15, we want to use the rule for 30, 60, 90 triangles to find each side of the triangle. So we have our 90-degree, our 60-degree angle, and I'm just going to go ahead and label that third angle as 30 degrees, just so that we can kind of see and compare it back to our rule. And so when we're looking at our rule, so that we can kind of relate just like we did with 45, 45, 90s, across from my 60-degree angle was my x root 3. So across from my 60, that's where I'm going to have my x root 3 side. Across from my 30 was my x. So across from my 30 is my x side. And then my hypotenuse, or across from my 90, that's going to be my 2x side. So if we know that my 2x side is equal to 12, the value of x is going to have to be 6. So I know that this side here is equal to 6. And then my last side, if x is 6, then I would do x root 3. So 6 times the square root of 3 for my third side. And there we go. We're all done with that number 15. All right, so number 13 and 16 are going to be the two that we do down here. So we're looking for all of the missing sides and angles of the triangles. And then this is the important reminder, we may need to use SOHCAHTOA to solve these. So now we're going to remind ourselves of some of these trig functions that maybe we haven't seen in a while. So let's take a look here, and I'm going to write SOHCAHTOA off to the side so that you guys can see it on my screen. Okay. So if I'm wanting to find all of the missing sides and all of the missing angles, I'm going to try to find, okay, so what is the measure of angle B? What is X? And what is Y? Those are the three pieces that it looks like I'm trying to find here. I'm actually going to change this. I'm going to write these in different colors just so that I can keep myself straight when we're doing this. X equals and Y equals. Okay, so let's go ahead and start with the angle. So in this image, we are given two different angles. We're given our right angle and we're given this 32-degree angle. So to find the measure of angle B, we know that the sum of the angles of a right triangle is 180 degrees. So if I know that I have an angle of 90 degrees and I have an angle of 32 degrees, then my measure of angle B is going to have to be whatever is left. So when I do this, I would do 180 equals 90 plus 32 is 122 plus the measure of angle B. I'm going to subtract 122 from both sides. So when I do that, I'm going to find that 58 is equal to the measure of angle B. All right, so we found that the measure of angle B is 58 degrees, and I'll go ahead and label that in my image as well. Okay, so now here's the interesting part. I don't have a 30, 60, 90, and I don't have a 45, 45, 90, so I don't have any of those shortcuts that I can use to find my X and my Y. But what I do have is I do have those trig functions that I wrote off to the side here that I can use. So if I want to find x, I want to figure out, okay, what trig function do I want to use to find x when I'm going to work off of my 32-degree angle. And the reason that I picked my 32-degree angle is because it's the one that was given to me, not the one that I found. So typically I like to work off whatever's given. That way I know that it's exact in case in my angles I did round somewhere. So when I'm looking at this, I want to remind myself SOHCAHTOA. So I have a side that's my opposite, I have an adjacent side, and I have my hypotenuse. So if I'm looking off of my 32-degree angle, my opposite side is going to be what I open up to. So my x is going to be my opposite side. My hypotenuse is always going to be whatever's across from my 90-degree. So my hypotenuse is my y side. And so the adjacent is whatever is next to my angle. So that's going to be my 13. So in order to find my x value, I'm going to have to use my opposite and my adjacent because I don't know the value of my hypotenuse right now. So when I look over here, which trig function uses my opposite and my adjacent? Well, that's going to be my tangent. Excuse me. So my tangent, and I always have my tangent of my angle, so of my 32 degrees, is equal to opposite over adjacent, so x over 13. So now I want to solve for x. So I could think of this in a couple different ways. I could think of this as doing cross products and doing x times 1, and then my tangent of 32 times 13. So that's what I'm going to go ahead and do. So x times 1 is x equals 13 times the tangent of 32. And when you type this into your calculator, you should get, let me just double check myself really quick, 8.1. If you don't get 8.1, make sure to check your calculator and make sure that you're in degree mode. So if you go to the mode button on your calculator and you are not in the one that says degree, make sure you change it to that. If you're in something else, it's not going to be working correctly. And we'll talk a little bit more about what the other modes in your calculator do later in this unit. Okay, so x is 8.1. All right, so there's a couple different ways that we can do this last one. So now we have two sides. I could use my Pythagorean theorem, but I do want to be careful because this 8.1 is a rounded number. So what I want to do is I want to go ahead and use another trig function so that I'm getting as exact of an answer as I can. So again, when I'm using my trig function, I'm going to go off of the angle that they give me and the side that they give me. So I have my adjacent. I'm looking for my hypotenuse. So the function that uses adjacent and hypotenuse, that's going to be my cosine. So I'm going to say the cosine of my angle, which is 32 degrees, equals my adjacent, which is 13, over my hypotenuse, which is y. So again, I'm going to use those cross products here. So cosine of 32 times y. I'm going to write as y times the cosine of 32. And then 1 times 13 is 13. And now I want to solve for y, so I'm going to divide both sides by the cosine of 32. So y equals 13 divided by the cosine of 32. And when I type that into my calculator, I should get 15.3. All right, let's do one more of these together. So number 16 uses a little bit of different pieces than number 13 did. So if you guys are looking at number 16, you guys should notice, compared to 13, we aren't given any angles except for our right angle. We're actually given 2 side lengths. So this one is going to work a little bit different. So again, off to the side, I'm going to write that we are looking for theta. So that's what this angle is called. We are looking for AC. So the side length AC. Okay, so when we do this, the first thing that we want to look for is AC because we're given side lengths, so we want to find what the third length is. So when we're looking at this, we can use the Pythagorean theorem to go ahead and solve this. So I could say 11 squared equals 4.4 squared plus my AC squared. So let's take a look. 4.4 squared is 19.36 plus AC squared equals 121 minus 121. You get 101.64 equals AC squared. I can take the square root of both sides. And let's take a look. So AC should be about 10.08. Okay, so, all right, let's take a look at finding that value of theta now. So I know, and I didn't write it over here, let's try that in. 10.08, I think our directions told us to round to the 10th. So I'm going to write this as 10.1. Okay, so now if I want to find theta, thinking about my SOHCAHTOA again, I am given my hypotenuse and my adjacent side. So taking a look up here, which one uses hypotenuse and adjacent? It's going to be my cosine. So the cosine of theta equals 4.4 over 11. Well, looking at this, I'm trying to find what's inside of my cosine. So just like when we were working with like logarithms, we remember that whatever's on the inside, we can't just multiply and divide by to get rid of. we actually have to use that inverse function. So just like when we were working with logarithms, we had to use exponentials. With cosines, we actually have to use the inverse cosine to solve this. So what I'm going to do is I'm going to use my inverse cosine of that ratio that we're looking at. So the inverse cosine of 4.4 over 11 is going to give me my angle. So when you guys are looking at your calculator, this cosine to the negative first, or this inverse cosine, should be right above your button that says cosine. So you should be able to hit like second cosine, and it will give you this. So when you do that, you should get that 66.4 degrees is approximately your theta value. So I'm going to write that up top, 66.4. The other thing that I do want to point out here is if you did find your theta value first, you could now use another trig function to find your value for AC. So if I know that this is 66.4, then now I would know what I would be looking for my opposite side, and I know my adjacent and I know my hypotenuse. So I could use either my sine or my tangent function. And I could say, and I'm going to use just the sine function because I feel like it right now. The sine of 66.4 is equal to your opposite, so your AC over your hypotenuse, which is 11. So doing that cross multiplication, you would find that AC is equal to 11 times the sine of 66.4. And when you type that into your calculator, you should get approximately 10.1. So just so you guys know, this one, you didn't have to solve it in the order that I did. I just chose to do that one first because that's what looked the most obvious to me, but it might be different for you. So please come see me during my office hours if you guys still have any questions. But you guys do have this worksheet on Google Classroom, and the answer key is going to be on there as well. So let me know if there's anything I can help you guys with.